Application security is hard when security is separated from your DevOps workflow. Security has traditionally been the final hurdle in the development lifecycle. Iterative development workflows can make security a release bottleneck. With GitLab, security is built into the CI/CD process. Every code commit is automatically scanned for security vulnerabilities in your code and its dependencies. Results are delivered to the developer in their native workflow for rapid remediation. Learn how GitLab enables DevSecOps. Visit securityweekly.com/GitLab for a 30-day free trial. The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. With 84% of cyber attacks targeting the application layer, securing your software is more challenging than ever. Synopsys enables DevSecOps with a portfolio of industry-leading tools including Coverity, Black Duck, and Seeker to help you build secure, high-quality software faster. Synopsys is the leader in application security testing. Visit securityweekly.com/synopsys to learn more.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined by John Kinsella and Adrian Sanabria. Would you like to have all of your favorite Security Weekly content at your fingertips? Do you want to hear from Sam and Andrea when we have upcoming webcasts and technical trainings? Have a question for one of our illustrious hosts, someone from the Security Weekly team, or wish you could hang out with the Security Weekly crew and community? Subscribe on your favorite podcast catcher, sign up for our mailing list, and join our Discord server to stay in the loop on all things Security Weekly. Visit securityweekly.com/subscribe. Security Weekly, in partnership with Cyber Risk Alliance, is excited to present Security Weekly Unlocked on December 10th, 2020. That's coming soon. This one-day virtual event wraps up with the 15th anniversary edition of Paul's Security Weekly live on YouTube. Visit securityweekly.com/unlocked to view the agenda and register for free. And that brings us to our news segment, which is going to be a lot of automation. So for those of you out here who are getting the Blade Runner references, throw on some Vangelis in the background. Or for those of you who are more of the industrial side of things, throw on some Kraftwerk, We Are the Robots. And with that, before we get into some of the automation after I just pitched it right there, one of the big things that was interesting this week is that the Cloud Native Computing Foundation released a white paper about Cloud Native Security, and about 44 pages of really good content. And John, I know you love all things cloud and containers for that matter. I'm curious, was there anything in particular about this white paper that really stood out for you?
Yeah, it was 44 pages. That's what stood out. No. And first, I need to, off your introduction, I need to make a comment or a request to our listeners and viewers: is automation is great, just don't automate the listening and watching of Security Weekly, because this is the important part. No, I thought this was a really interesting, fun paper. A little long to say that, right? Fun and 44 pages of security text is I get it. That's not everyone's idea. But I think what was really interesting is, while this came from CNCF and people instantly think CNCF and Kubernetes, they did a pretty good job of distancing themselves from that. As a paper written by an open source org, it doesn't feel like that. So, if you would think like, I don't want to point any fingers, but if you think like, if you've seen a white paper come out of an open source organization, it's usually really technical and heavy, and it can be a tough read. This was purposely aimed more towards management and executives, C-level type folks. They actually talk about orchestrators, like I said, not specifically Kubernetes, but I think they've done a pretty good job on the paper. And again, open source, and go keep banging that drum. So as people read this over Thanksgiving week, while you're waiting for the turkey digest, and you see something which could be improved, realize you can go and help these people actually improve this and make this better for our next release. So that's what I thought about this.
Yeah, and for me, I thought I enjoyed the organization of it, because they focus on the life cycle and they break it down into develop, distribute, deploy, and runtime. So they almost got the DDR for Dance Dance Revolution, but they went triple DR in this case. But a couple of things that stood out to me from that were they really focus on testing, and we've talked about that before, and security testing should be part of this. They talk about that. But also part of their distribute is artifacts and images, the idea of not only just hardening them, but signing them and making them immutable, for example, but having that trust basis that we've, a theme that we've talked about in the past, from all the way that code commit to the fact that what you've built should actually match the code that you committed, and then the code that you built is now the same code that you've deployed. So a really interesting area there and a good emphasis. And the other thing too is that it talks also about, under the security assurance section, threat modeling and zero trust as well. The idea that we are in a new modern environment, and therefore we're not just gating everything on IP address spaces, or there's not really a concept, or it's not as important to discuss this is inside the network, outside the network. It's more of who's accessing my resource and how much trust do I have with them. So a couple great concepts in there, and I think it is quite up to the reader, though, the exercise to figure out, okay, great, but now how do we implement this? And that's where they have to figure out, is our orchestrator Kubernetes, or is our orchestration approach something else? So great paper. Yeah, go ahead.
Really briefly on that, because this ties back to our previous segment about threat modeling, which I want to mention. You were dancing pretty closely for a moment, talking about complexity of environments and how do you threat model those. You're asking me about containers. How do you threat model something around Kubernetes when you've got all these moving pieces, right? This gets super complex and it can be an armful, right? Which is why I tell people not to run Kubernetes themselves if they don't have to. Go use one of the cloud providers. But for people who want to bring that segment in and bring that into Kubernetes, this paper would be a pretty good place to start thinking about that.
Absolutely. Great way to set the foundation for your security program, so you don't have to write it from scratch. That gives us, I think, a good segue into the idea of moving into the cloud. Or there was also the certificates and roots of trust as part of that security white paper. And Microsoft has announced the Pluton processor, which is basically they're moving a lot of security capabilities right into the CPU. And they highlight a very important aspect is that if you an attacker have physical access, or if you can intercept the communication bus between the TPM, this trusted module, and the rest of the CPU, then there's a pretty weak point there. But they're pointing out here now with much like Google has been developing their own chips. We just heard recently about Apple also developing their own chips with the M1. And there's all of these ideas of system on a chip or security enclaves. This seems like a natural evolution of design. And Microsoft is definitely following through here. And I think it will be, as I'm scrolling through my notes to find out other interesting points I wanted to make about this. I just thought it was really neat to read through that, as well as it had two links, one about the 7 properties of secure systems. And I thought those 7 properties are pretty universal because they also talk about roots of trust and things like that. So I'm not sure, Adrian, if you've had a chance to read through any of these yet, or what your thoughts on this might be.
Yeah, so yeah, this is it looks like they're basically they're producing their own equivalents to Apple's T2 chip. So traditionally, if you have like a business class Lenovo or something like that, or an HP that has a TPM chip in it, that's going to be manufactured by a third party. And we saw Apple, one of the first things they did with their own silicon, in addition to putting platforms, systems on a chips in their mobile devices, was to introduce their own T2 chip, their security enclave, that would handle a lot of the secure stuff around, storing and processing fingerprints, the biometric reader with a Touch ID, dealing with the boot process, doing that securely. You'll notice on a lot of these devices, you have to enter your password first to enable Touch ID or some of these biometric processors. So yeah, this isn't going to replace your main chip. What Pluton is going to do here, it looks like you might see AMD integrating with it as well. is it's going to accompany it. It's going to be a new option for manufacturers to include as a TPM chip, or we may see it become part of like the i5, i3, i7 chipsets, which include a lot more than just the main processor. So this is complementary to your main chip. I wouldn't compare this with Apple's M1, for example. That's more of it's actually a new concept for a desktop or laptop PC entirely. The idea that the RAM, main processor, GPU, all that is squished into one component there.
So,
yeah. Go ahead.
I'm a little confused. And this is interesting, right? So this is as the paper says, this is we've talked many times this year over Sphere and some of the other stuff Microsoft's been working on. So they've been working on this for a long time. It actually goes back to Xbox. It's pretty amazing from that point of view. This feels to me like it got a pretty good amount of paint from the marketing department. And I obviously, for those who listen over the year, how I've talked about Microsoft has changed over the year, from being very doe-eyed and sparkly-eyed and, oh my God, Microsoft's spending $1 billion beginning of the year. Wait, so we have a TPM. Intel has a TPM, AMD has a TPM, as we said, Apple has a TPM. It's not clear to me, is this going to be an additional to that? Is this only going to be in desktop class chips? Is Intel now going to start to just talk about Intel for a second? Are they going to be making an i7 or an i9 with, because it looks like it's actually in the core, Adrian, not outside, if you look at their diagrams. Are they going to now be making two separate chips, or is it actually outside? That would make more sense. They're talking about, they're using the exact same words as Intel said, saying that people who have physical control of something aren't going to be able to get the data out of it. Intel might want to sort of catch you up on some of their recent events around that, because that's not necessarily true. So I'm really curious to see where this goes. It sounds nice. I'm not sold on this one, to be honest. We'll have to see, I think.
And that's I'm
kind of speed reading here to catch up, but yeah, from that diagram they have there, it does look like they're referring to a system on chip. So if they're going that route, then because they don't manufacture CPUs, that's going to have to be a collaboration with Intel and AMD. So I would assume that would replace the TPMs that those chip manufacturers already have.
And Intel right now might be very happy to replace their TPM, but anyways, keep going, Mike. We'll see where this goes.
We'll see where this goes. One of the places it goes is into the past, into the last segment, because I wanted to tie it back to what you were kind of getting to there, John. I think is a little bit of threat modeling in the sense of, great, we have a secure, a security chip in our core. What is it protecting us for? What benefits are we getting out of it? And I think that's kind of, reading between the lines what you were saying, which is a great threat modeling question. And it does have a pedigree here within the Xbox, so a lot of it is focused on content protection for that matter, but as well as countering cheating, things like that. Because it's more likely to have physical access, and that's the type of perhaps a threat scenario you want to protect against. But as you were pointing out, last week we were talking about Intel's average power detection, RAPL, and how that can be used as a side remotely through software to infer information inside the enclave, these secure enclaves, for example. And that does bring us to perhaps a weak segue, but a segue nonetheless that I'm going to take, is that we are still going to have, with all of these chip-focused security approaches, they're protecting secrets, essentially, or protecting certain types of computation. They're not protecting us against stack overflows or heap overflows, for this matter. And one of the interesting things I came across was a gentleman, Sean Heelan, who posted his PhD thesis, and he had written about automatic exploit generation in heap overflows. And this really stood out to me as kind of interesting, because it was looking at, rather than stack-based buffer overflows where you're getting ostensibly some protections like ASLR, things like that, the heap has a is a different beast. And he was looking at this similar to like the DARPA Grand Cyber Challenge and things that we've talked about in the past, of just to say, if we know a vuln exists, how can we automatically generate the exploit for it? So it's sort of a different take on fuzzing, if you will, because we've touched on fuzzing concepts a little bit in the past just to find vulnerabilities. But this was really interesting reading. So for those of you who want to go beyond 44 pages onto, I think we're into 100 plus pages for this thesis, you can read more about some fuzzing as it applies to exploit generation. And I'm not sure if there's anything there that might have stood out to either of you guys in that particular paper.
I have to in full honesty, I have not read all 100 pages. I know that's going to shock you. It looks really cool. Because that's one of we've talked about, again, I'm talking about a lot of what we've been talking about, but fuzzing is easy, right? It's what do you do with those results, and then how do you actually take from that fingerhold and actually compromise. So I think it's really cool what he's attempting to do here and what he's talking about.
Yeah, I think the other.
So there is.
Go ahead.
Yeah, there are some endpoint security products that aim to, address these types of exploits, like the exploit classes entirely, with more general approaches. And I'd be interested to see if any of those, if this gets past any of those. But the idea, with the buffer overflow, things like that, the idea is these endpoint security products will inject a DLL into every running process, say in a Windows host, and will keep an eye out for these kinds of techniques and prevent them from hitting the host if they see anything that looks like a buffer overflow or some of these different techniques. But and then there's others that seek to obfuscate memory, or randomize it, in some way that frustrates these kinds of techniques. But if you're fuzzing, if that could defeat those approaches, because generally those are relying on known vulnerabilities. And somebody writing an exploit for a known vulnerability, say in Acrobat Reader or something like that. If you move things around, it's not where the exploit code expects it and the exploit fails. But if you're going to fuzz in real time and then exploit it, that could bypass some of the products and protections that we have out today.
Yeah, one of the reasons, the other reason I wanted to highlight this too, I think it's a good complement to our threat modeling discussion, because it's kind of as we were pointing out there, Adrian, is this can be a good way just to confirm, are the defenses that we've deployed appropriate for the threats we think they can protect, or how are they adjusting to new threats we see emerging? So one of the interesting things here is that these heap type of attacks or heap overflows aren't necessarily going to be affected by ASLR, or even if you look at the recent like with iOS recently, we're using pointer authentication codes. Again, those are really focused on protecting the stack, but these use after free or other type of heap-based attacks that this thesis was focusing on might be, that's not where those protections are necessarily focused. One of the other things, though, that the paper was highlighting is that it sort of did a little bit of hand-waving and said that, control flow integrity is a pretty solid protection. It still may be fuzzable. There may be some ways of doing some fuzzing to get around it, or figuring out how to preserve your control flow integrity of the exploit itself. But for using your LLVM, which is one of my favorite open source tools out there, that's one of the things that CFI can be a pretty good control. So if that is applicable to your compiled code that you're building, that could be one of the things that is helpful. And this could be a good way of just figuring out, are we protecting our binary as much as possible, or what are some other ways we could be adding some defense in depth, if you will, to the code we're writing? But speaking of
the time-honored tradition of leapfrog and InfoSec playing leapfrog with attackers and researchers.
The whole pointer, and you had a few interesting links around this, Mike, but that whole space around how do you make sure someone's not manipulating your memory addresses or your pointers and those type of things, ASLR and everyone else. Some people have sort of teeth gnashed over them at them over the years, saying that's randomization is not a great way to do this when BSD was doing it, Linux was doing it. I hope I got that right. But at the same time, it seems like some of those techniques are getting a little better. The Apple stuff that's coming out or I guess it's out now in the Series 12 and newer A12 and newer chips. So as they start doing more fancy, more mathematically based approaches versus just doing some randomization, which some of the stories we talked about in the last week or two. Again, let's see how much I can back reference. But the stories around voltage measurement on the CPU were able to actually figure out, I think it was within 30 seconds, what the ASLR offset was. So yeah, it's some of those are getting better, but it's by themselves it looks like, combined with this white paper, that might not be standing as a secure option some more.
Might not be, but I do want to make sure we highlight, is again in the spirit of our threat modeling segment, that just because this is not necessarily the attack you need to be worried about, because we have a pair of articles here, one about bots scanning the internet, surprise, surprise, but in this case, finding secrets in environment variables that are stored in files, so in .env files, basically, and another one about really old school attack on file extensions and mishandling within Drupal. So I don't know. So those are. It just kind of points out at a high level, putting secrets into files is still going to be bad. And my brain just broke. And if you didn't realize that, then that's a bad thing. Don't put secrets in files or in code, because scanners and people are out there going to look for it. What can you guys save me here? What can you guys add to that while my brain?
The one thing which really caught my attention on this, and I'll toss over to Adrian, is they're not just the bots. It seems like they're not just searching and finding those environmental maps, and they're not using them. That's the interesting part. So they're creating a cache right now, which is a little more worrisome still to me. That means either someone's just going out there and saying, "Hey, what env files can we find?" And the article actually lists a bunch of paths which they're looking through. Are they just purely academically doing that, or is someone actually gathering this stuff, and we're going to see phase 2 coming along fairly soon?
Yeah, so it's interesting. Andrew Morris and Gray Noise is a good place to look for that kind of intel, because that's the whole point of Gray Noise, is to catalog and try to identify some of those sources scanning the internet. But yeah, I would assume the worst for now. And the thing is, this is an old vulnerability. Yeah, back in my early days of pen testing, one of the key things I would look for are these kinds of environment files. Back in I don't know if people use J2EE very much anymore, but I'd look for those .properties files. You find like a db.properties or something like that. You find JDBC connect links with the username, password, name of the database, IP of the database. It was just kind of like a one-stop shop for the rest of the stack below the web server or the application server, and the customer would be pretty much done from that point. But I've noticed that a lot of new technologies come out, and we tend to still make these 1990s mistakes of exposing secrets in text files. And things like that. So that's always something to look for. I mean, that should have been in your threat model going back to the late 90s, early 2000s, and it should still be there. Clearly.
Yeah, I think to me, that's also one of those aspects that really should be call it a solved problem, in the sense of finding it. So Adrian, you'd point out, Equifax, one of their real challenges was figuring out just where do we have struts. In this case, one of those questions should be, where do we have .env files, and can we find them? And that is something that should honestly be quite solvable as part of your SDLC, whether it is, scanning your code repo for simple file names, because those are predictable file names, or scanning arbitrary file names for content, because RSA keys, a lot of these have actually predictable patterns within them. So this isn't so much, I think, a problem of do we know about it? It's sort of more of the what should we do about it, to go back to one of our threat modeling questions. And the what should we do should actually be pretty easy, because there are tools scanning for this. And if you're thinking of the other aspect I want to pull in here is the idea of bug bounty, is that if you're just having a bug bounty and getting these types of vulnerabilities reported, you're essentially subsidizing 100, 1,000, a whole bunch of people running all these scanners themselves and paying for that, when you could have just run the scanner once yourself and found it without the extra overhead of bounties and so on. So that's the other lesson I really want to throw there.
I wonder if all the companies out there doing attack surface mapping are looking for and detecting this kind of thing, because that's the whole idea there, is you outsource that process of looking for low-hanging fruit on your own IP addresses, on your own websites, to these external companies.
Indeed. And that's what was also interesting about the Drupal vulnerability, which was basically mishandling file extensions in PHP, which, if we are going to turn this into the history of security, also goes the 90s. But what is interesting there, that to me brings that idea of the threat modeling, in the sense of that fourth question, how are we doing? In this case, it seems sort of like every time we talk about, we came across this in the 90s, one of the other questions should be, why did we forget about this? Or did we lose the memory of this type of problem? Because one of my pointed questions for this would be, where was the acceptance test, or where was the security test that would, verify this very specific type of well-known scenario? So that was kind of interesting from my perspective, as sort of a process issue, if you will, or a weakness that they may have applied some threat modeling, but they haven't done that fourth question and paid attention as much to say, we know this vulnerability existed once. Let's build some way to find and test for this vulnerability overall time and into the future.
So in this case, it looks like the failure was in making exceptions. So we'll see a lot of good controls and practices and things like that, but then we'll give certain people within the organization an exception, or certain trusted processes or applications an exception. In this case, it looks like they were aware of this being a vulnerability, the double file extension, but certain files were exempted from that check.
I think, John, you wanted to add something as well?
Probably. Don't I always? No. So what I was going to say is, I was going to take a step back and look at this from the lens of Drupal's been around, where I've lost track of what version they're on. I think they're on version 8. But they've been around for quite a while. They used to be in the top 2 CMSs, if not number 1. That article calls Shopify CMS, which was interesting, but point being, this is a more mature open source organization. They've got a pretty good security team. They're usually staying on top of things pretty well, but still that group of folks that had a little more maturity, and the VC invested in I believe Drupal, the company itself, they still aren't able to go back and remember everything from the 90s. So it's just the point here being, this isn't as easy as we make it sound, right? Even if you know this stuff, do you have the time to test every single thing every time? How do you test it? Do you get a third-party tool, as Adrian was saying, or do you actually write all these unit tests yourself? There's more balls that you're being required to juggle as we go through these hours. So that's unfortunately part of it.
And that's a good point.
There's an opportunity for defense in depth here too. Sorry.
Defense in depth. Bring us around, please.
Yeah. So I mean, you're unit testing, but also in production, your WAF should be disallowing, attempts to access certain file types that aren't relevant to the application, that represent sensitive files, configuration files that can save your, just little WAF checks like that can save your bacon when somebody makes a mistake.
Yeah, I think that's what we can bring us to the final article that I think kind of ties a lot of these ideas together. It's about, it was from DevOps.com. It's about talking source composition analysis, and something to think about. We talked about this quite a bit, but one of the things that stood out to me is that this article has a couple of bullet points, but one is depth of checking, which just asks how deep does the tool go? And I think that kind of gets to the point that John was just saying at the end there, is that very often it's easy to say, well, just use this tool, just look for this vul, look for this file extension. But there are nuances there. So one of the things is also that's important is understanding what's my tool capable of finding, and hopefully also being able to answer, do I have a good sense of what the tool isn't going to be able to find, or what the limitations are of the tool? Because with that knowledge, that can also feed into additional threat modeling exercises to figure out, we're protected here, but here's our other gap where our tool maybe can't be as efficient or as deep as it needs to go. Now we need to step back and start to threat model about what this gap is and how impactful do we think it might be, and what's the next step we want. What are we going to do about it? Is that question that it's going to set up.
And I tie that back to your our conversation around documentation, right? No tool is going to be perfect, but okay, here's homework for our listeners. If you're using a scanning tool, back to the Drupal example, now go back and look, is it actually scanning for that double extension type vulnerability, right? And don't throw the tool out if it find out it doesn't, but now you've documented, like, how do you fill that gap? How do you mitigate that, right? Security should be around mitigation. And the same thing for this is maybe you're just using a tool which has only been around long, because a lot of these SCM tools are fairly young. I know some are older, but maybe you're using a tool that's only been around long enough that they haven't figured out the chess move of, or, you know, as we're saying, the leapfrog move of, we have to keep going down the rabbit hole and finding what else is being included. Okay, you know that. Don't throw the tool out, whether you paid money for it or you like it or whatever the reason. Maybe later throw it out. But how do you actually now go mitigate that for right now and figure out what you need to do next? That's sort of what people should be thinking about there.
No, I think that's great, and I think that's a deep-cut reference to Blade Runner, to stay on theme, to talk about chess moves, so I appreciate that, John. Also appreciate John and Adrian for joining me this week to talk about the news and our threat modeling deep dive. You could also refer to the three of us as Klaatu, Barada, and Nikto if you wanted to keep on our theme of robots. Thanks, everyone, for joining us. Thanks for chatting with us in the Discord. We'll see you next week for Application Security Weekly.